everyone, welcome to our class. Today we are talking about a plant disease which is a fungi. It is striped rust. It is also my project. What you are seeing in the field is my experimental field. So we have already talked about the disease triangle, which contains three parts: the environment, host, and pathogen. So today I'm going to separate them into three parts and explain how the striped rust developed on our cultivar, wheat. Okay, first I would like to talk about the environment. Once the environment is favored to the striped rust, they start to development and sporulation on the wheat leaf. Okay, so we are located in Davis, and the temperature here now for daytime is 10 to 20 degrees. During the night it's around 0 to 10. It's a favorite temperature for striped rust, and the striped rust can survive under 25 degrees. After the 25 degrees, they will die because of the heat. Okay. So now is the spring quarter. As you know, it's April. Starting from the January, there's a lot of rain. So during the winter and spring, the humidity in the field is probably more than 80% and to 100%, which is very favorite for the striped rust to develop. And I also want to mention that there's another characteristics of striped rust is they can transport by wind. So the spores can transport by wind and far away from the inoculation site. This is my experimental field. And this is a PST, which is striped rust nursery field. You can see the border on my right hand and all around the plot. So in the middle are our cultivar that I need to screen out, which is resistance, which is susceptible to striped rust. However, we want this screening to be uniform, which we need to challenge every individual by the same stress pressure of the striped rust. That's why we inoculate the border first when the time and the temperature is good enough. As you can see, the striped rust in the border have already developed. And go down here. The border will help us to develop full of the spores on their leaf. And when the spores are germinating and developed in the full leaf, the spores will spray by the wind, and it will keep challenging my field plants and make sure every individual plant can have a high pressure of the PST. So in this case, when we are doing the field phenotyping, we know we have the confidence to say that, oh, they have been going through the high pressure of the PST, so we can trust our data collection. Now I would like to talk about the second part, which is the host. The host I'm talking about today is wheat. So wheat have many cultivar that some of them show resistance to striped rust, some of them show susceptible to striped rust, some of them show partial resistance or partial susceptible. We need a system to evaluate that which cultivar is resistant and which cultivar is susceptible, or how much they can resist, how severe it is. So we have a scoring system called MAC notes. From 0 to 9, we give them scores. For example, the 0 is the clear leaf, which you cannot see any spores germinating from the flag leaf. Or the 9 is the very susceptible one. For example, you can see in the field, like the border I use is a very susceptible cultivar, which called double dwarf. It is relatively shorter than the general wheat, so that we use it as a border to easily distinguish them. And you can see, for example, come here, take a look of this. See, the petals are full covering the wheat leaf, which we usually give them the score as 8 or 9. Okay, the last part I'm going to talk is the pathogen. The striped rust is called Puccidium streamform. From the inoculation, from the beginning of they get in touch of the wheat leaf until you can see the sporulation, or you can see the pastel on the leaf, it only takes 10 to 15 days. So after the first sporulation, the spores can fly by wind and attach to other leaves, for example the clear leaves, and do the secondary cycle. So we have already talked about their life cycle, which is very complicated. And the spores you see in the field is uridial spores, which we also call it summer spores. So how to prevent the striped rust to be a big disaster or make a big yield loss? We have many ways to do the field management. And today I want to point out 3 important points. First, depends on the disease curve. So striped rust disease is following an exponential curve, which tell us that as early as you can to stop them development. So in the later stage, when the wheat are already mature, it won't cause a big problem. Otherwise, it will cause 30 to 50% of yield loss. So considering the exponential curve, we are going to use the fungicide at the very beginning of the disease. For example, when in the early winter or in the early spring, that we figure out, oh, there's some spots in some very susceptible plants, we detected it, and then we use the fungicide to stop them in the first cycle or in the first several cycles. And also we can remove the volunteer plants, which means after we harvest this year's wheat, there are probably some leftover wheat in the field, or some seeds we didn't collect it. So we want to make sure you clean the field, don't left some volunteer wheat in the field, because the uridial spores probably can turn into tallus spores when the temperature is super high or the environment is not favorable for their development, and they can survive during the summer or during the winter for the next year germination. The third way to manage this disease is doing the rotation. Next year, the host is not gonna be the PST's host, which can cut their life cycle effectively. Of course, the most effective way is to use the resistance cultivar, which need our scientists and breeder to select in the field, or also select in the wild resources. So today is like 1 week later, it's April 9th. Let me show you how the border are growing for stripe rust. You focus on all the leaves. As you can see, the leaves. For example, this one is a very good example. You can see the stripe rust is full of the leaf, and it takes like area 80 to 90%. So we give it a score like 8 or 9. For this week, most of my seedlings in my population are not heading yet, which means we didn't see the spikes showing out yet. Comparing to the border, you have already see the border have already show up the spikes, which is good because we want the border to sporulation first and then infect or secondary infect of my population. So as you can see, most of my population seedling have already booting here. So this is the flag leaf, as you can see. So we will wait until next week to see the infection for the flag leaf. The flag leaf is the most important leaf for wheat production. It contributes 50% of the yield. That's why we care about whether the PST can cover how many percentage of the flag leaf to reduce the the phenotyping of the flag leaf will be the final decision that how much score we give this plant of their resistance to stripe rust. Okay, so next I would like to introduce the susceptible lines and resistant lines for my population as the population's parents. After the rain, like last week, we have 2 to 3 days rain. The stripe rust starts to germinate on my population, and here I show this. So this line is the resistant line for my population, and you can see the leaves are most clear, and some downside leaf have some discoloration spot. And let's move to the second row. This row is susceptible parent. And you can see the sporulation and the pastel on the leaf. So you can see here the pastel have already shown on the leaf surface. And this level, like this score, we will give it 5 to 6. And when the temperature is higher, around 20 to 25 degrees per day for daytime, the stripe rust will develop super fast, and then the full leaf of my susceptible parent will be covered by stripe rust pastel. I will show you it next week. Okay. Today is April 18th. When you see the seedling have half percentage or 50% of heading, it's a good time for you to do the phenotype in the field. Let's check the resistance and the susceptible parent. What are they going to look like? This is the susceptible lines. You can see, come here, you can see the leaf. It's full of spores. It's almost covering like 80% or 90% of the leaf surface.
Okay.
Okay. comparing to the resistant lines, you can see resistant lines is almost green on their flag leaf, right? But it still have some necrosis spot on the leaf surface, but it show resistance. I always forgot to record an ending, but yeah, this is all for this year. See you next year.